the smartest people that I've ever met in technology. Gary Flake and Adam Bosworth, who are both with Salesforce.com. And I'll ask each one of them to introduce themselves. So, Adam, why don't we start with you? Tell us about your background and what do you do for Salesforce?
My background primarily is building democratized extensible platforms. I built one at Citibank for helping people manage their businesses, put about 100 MISs in place, built one of the first spreadsheets, but with extensible programmability, Quattro. Went to Microsoft, helped build the way to make it easy to build Windows and client-server applications. Then did the same thing for the web. Went to BA Systems and helped make it easy to build enterprise Java applications. Went to Google and made it easy to build collaborative apps, Google Docs. And then in the meantime, I've been collaborating with and helping Mark all along at Salesforce, and finally came to Salesforce to help make an easy, extensible platform for sort of this big mobile monitored world we now live in.
So what is your, so tell us just briefly a little bit more about your role at Salesforce.
I really have two roles. One is to make sure that we're doing the organic innovation we need to do, particularly around, again, platform. And then the other one specifically is to make sure that we build the right platform and the right product for what we've been calling the IoT Cloud, which is a platform for enabling customers to deliver literally billions or tens of billions of events a day from their customers and their customers' devices to a place where they can effortlessly digest that, distill that, and use the digested, distilled 360 profile about that as context to process all those events in near real time and cause the right business value to be generated from it, to get the right things to happen, the right service events, the right opportunities, the right information, the right customers and partners to actually make their customers' lives better.
Okay. And Gary Flake, tell us about your background and what are you doing at Salesforce today?
Yeah, so I've been working in machine learning, data science, internet-related things, those kind of areas for almost 30 years. My original background, my PhD is in computer science and in machine learning. In the 90s, I spent most of my time in different types of research labs for in the government, university, industrial labs. So I became something of a student of failed R&D research models. I, like a lot of people with a machine learning background, I made the transition to looking at a lot of data on the web in the late 90s. And post 2000, I had a lot of different roles in some very important companies. I was lucky to be a part of, I was the chief science officer of Overture, which was the company that invented paid search. Yahoo acquired Overture and I founded and ran Yahoo Research Labs. I was a technical fellow at Microsoft where I ran a group called Live Labs. And I did a startup, and now I'm actually the CTO of search and data science at Salesforce, where I run, along with a phenomenal team, the entire search infrastructure for Salesforce. And along the way, I also wrote a book called The Computational Beauty of Nature in the 90s, which is a textbook focused on complex systems and adaptation.
So what we have then between you two is the intersection, in a sense, of Internet of Things as well as search technologies and analytics. And so how do these intersect?
I'll jump in here and say each is the yin to the other's yang in some sense. Each is fuel for the other. And I would add machine learning, AI, data science to that mix as well. What's really interesting about the current time that we're living in right now is that we've seen finally this great convergence of data that is a side effect of many different internet services and soon to be accelerated even further with IoT. We have seen compute power through the ubiquitous deployment of cloud-based infrastructure. And we've also seen the development or refinement of different types of algorithms for making sense of these things. And so in combination, the compute infrastructure and the data becomes the fuel that makes machine learning and artificial intelligence much more productive. And in turn, these machine learning and AI systems have an ability to produce massive quantities of data on their own, empowering a new generation of devices and services to be operating somewhat autonomously on the web.
Yeah, I think that's exactly right. I mean, as a concrete example, I met yesterday with a large electric company. They have 33 million smart meters. They generate power from multiple countries in multiple different ways and modalities. And we're busy focusing on how do we get the data in about what's going on with those meters and the generators and the power and where's the power. But what they need as much as that is they need to then apply data science, both predictive and intelligent, to figure out how do they best balance that, how can they best learn which customers will use what when, how can they best actually figure out how to encourage customers to change their power consumption behavior in ways that would be more efficient. Everything that they asked me about was about data science, data analytics, and predictive analytics and big data. And they're a company that will be generating about 33 billion events a day. 33 billion events. That's right, a day for us, pretty quickly, just from their meters, and then growing from there. So, we're seeing just really large amounts of data come in, and yet the customers are really interested in saying, it's too much data to look up by hand, it's too much data to understand. How do we take data science at really large scale and figure out what we need to start creating the kinds of benefits from this data that we want? So I think it's exactly correct. The change to a mobile and monitored world has created a huge demand for the data science, for the predictive analytics that is necessary to try and control and manage this kind of information.
Now, one common thread that you just mentioned is the application of data science and analytics to solving customer problems. So maybe can you elaborate on that?
Well, I think Gary does a better job, but just quickly, what they want to do is every customer that I speak to, literally without exception, wants to predict behavior on the part of customers, employees, and partners. What were they likely to do? What are they likely not to do? What segment do they belong in? What are they likely to purchase? What problems they also want to predict behavior on the part of devices. When will this machine need to be serviced? When will this machine break down? What is the likelihood that we'll have a failure case? Is it likely that this thing actually needs more power or a different environment? So there's a lot of prediction that's about behavior and a lot of prediction that's about hardware and physics. They want to do real-time analysis on some of the events where they need to respond really, really quickly in the event that something goes wrong. They want, to actually then test alternate strategies. And what they all want, the holy grail, and this is sort of completely up Gary's alley from his PhD and from everything he's done since, probably most importantly is they want automated self-improvement systems. They want a system where the more data you get, the better the system behaves, and the more you know how it worked, the better it does, so that every time you're trying something, that information is continuously making the system better and better. Gary, you should take over because you have more experience with this.
Well, that's generous of you. But one thing I'll add, I'll make something of an analogy between the phase of development that we're in right now and what has happened historically, for example, with transportation. So a couple hundred years ago, if you wanted to cross the country, there were very few options for you, but you may have ended up doing something like a stagecoach, where the person that was responsible for transporting you or helping you get across the company had a very high touch relationship with typically with his passengers. And that path of being a stagecoach operator was arduous. It was difficult. You knew all of your passengers, and it had limited success. Later on, trains made their way, and the role of the conductor was such that the conductor may not actually know everyone that's on the train, but they're responsible for taking a bigger volume, a bigger mass across a greater distance at a higher speed. Now we have, then airplanes came, and now we're doing, it's a mode of transportation that no human, that there's any sort of natural analog for a human. Humans don't fly. Humans don't naturally in any way move at that kind of speed. And now when you take a look at the latest generation of aircraft, in some ways, what the pilot is doing is no longer flying anymore. They aren't actually controlling something in the most advanced planes that are actuating the different portions of the wing to have the changing the angle or anything like that. What they're doing is they're interacting with the plane through a metaphor. The metaphor is, I want to go in that direction or that direction, and the system knows how to translate that into actuated movements of the physical equipment. So in that process, what has happened is that we've gone through a phase where transportation resembled something that we once naturally did, but now transportation is completely unlike how we as humans actually naturally move. And the role of the pilot is actually very different. And as a result, instead of merely being able to go one times, like twice as fast or three times as fast, we can travel now hundreds of times and faster than what any human could do. With transatlantic flights, vastly further, with more people than nature would have ever allowed us to produce. Now, connecting the dots between that metaphor or that analogy to where we are today, the person that is interacting through a big data, a data science, an analytic, or a machine learning system, in the past, they would have to look at individual records, individual things, just like a stagecoach operator, and somehow having to negotiate over every single bump in the road. As things have become more automated, the ability to scale to more entities, more pieces of data, it has gotten even more powerful. But now with automation and machine learning and analytics all riding on top of a larger system, the role of an analyst sitting on top of this information is no longer to look at every piece of data piecemeal. It's to actually help guide a system to yield a richer, an ever richer form of analysis, an ever richer form of insights. And this is the sort of thing where what the human is doing in this is no longer about the manual labor, if you will. It's much more supervisory in terms of teasing out hidden patterns, hidden signals. And in that way, what one person can do with a new modern analytic system is akin to what a pilot can do on an aircraft. We can now do things at a scale, at a speed, at a volume and velocity that no human could ever naturally do with the power of their own mind. But by working through a big data and machine learning system, we get a multiplier on what human can do that is perhaps thousands or millions of times more productive and more powerful than what a human alone could do.
Adam, this notion of the relationship of the human to the data and to the technology, maybe you can elaborate on that, because that seems to be an indicator of where our future is headed.
Well, my favorite example, and funnily enough, very opposite, because this actually happened this week again, is my wife has a monitored car and a mobile app for that car. And periodically, mysteriously, this light comes on, which is the engine light. And she knows that the car is monitored. And so her point of view is whatever sensors, whatever computers inside the car figuring out that the engine light is on should also be known by the car vendor. And then therefore they should know what's wrong with it, how long it'll take to fix it, which dealers can fix it, who has what availability, understand her schedule, and have automatically, before she ever sees the light, have suggested to her that she needs to go there and get a loaner and drop off the car. And what you have there is an expectation failure, because the expectations, my wife is not technical, are if you're monitoring something, you are predictably intelligent about it. If you are monitoring something, you're watching 24/7, you are smarter than any human, you can scale in the ways Gary just said. And if anything is about to go wrong or gone wrong, you have already figured out what to do and have already put together a plan to help before you even find out as a customer that the light is on. Obviously, that's not her experience. Her experience is 10 minutes on hold. The dealer says, I don't know what's wrong, bring the car in, I have to look at it, read the computer out of the car. And her general attitude is, well, you guys are bozos. So the human expectations have been changed profoundly by the concept of things being monitored. And they've been changed to say, if you're watching 24/7, then you should be able to be as smart as a human, but scaled infinitely up across all the kinds of learning that we just discussed. And if you don't, you're not delivering to me the quality of service and support I expect. And that is a very interesting time that we're in, where as a human, you're now expecting these things to notify you. Expect your smoke alarm to tell you before the battery starts beeping and waking up your kid at 2 in the morning. You expect the car to tell you before the engine light goes on. We see these cute things now where you expect the car to park itself, so because you can't get out of the door if you do it. That expectation is actually moving, if anything, faster than the software. Not because the software can't do it, because the companies are very slow to take advantage of the software. Gary's absolutely right. Moore's law has been unbelievably powerful in taking things that were well understood a decade or more ago, but were just not necessarily cost effective, and making it possible now to scale at a completely different level. When I got to Google in 2004, I was just stunned by how could you type in this query against 1 billion pages, sites, and boom, back came an answer, until I went and looked at what they were doing. And really what they were doing wasn't as much brilliance as brute force. It was a brilliant application of brute force and Moore's law, and the fact that memory and computer speed had both gotten massively cheaper and massively bigger and massively faster than had been true when I started in computers. And people's expectations have changed very quickly. When my son speaks to the Echo now, if the Echo doesn't understand them, he gets annoyed. His expectation is that the Echo should understand them. And, by the time he's my age, he'll be surprised a human would drive a car. In fact, forget my age. By the time he's able to drive a car, he'll be surprised that a human would drive a car. He'll be surprised if he can't tell the car the directions. This kind of expectation is just moving at an extraordinary speed compared to what we've seen in the last 2 decades before that.
So Gary Flake, is that your job in a sense, is to meet these kinds of expectations for your customers, essentially help your customers meet these expectations for their customers?
Well, that's a lot of weight that you've just put on my shoulders. I have a lot of jobs. I wear a lot of hats, and the job that you've specifically mentioned is something that we all care about at Salesforce. So it's everyone's job, not just mine. It's Adam's job as well. And I love how Adam puts the change in psychology that we're seeing in people in terms of what is, how our expectations are changing and how we expect to interact with devices. I've seen it with my own kids as well. My 2 boys are of the same generation as Adam's youngest, and I love watching how my kids interact with Alexa, with touch interfaces, and things like that. And they, just like Adam's wife, and just like my wife, and everyone in my family, we all have we have a ever increasing, rising bar for what we'd like to see. And I think that we're at this interesting crossroads in the history of computer science and the history of machine learning and data, and that never has so much changed so fast. We've had a number of different historical milestones that you can cite on one hand. One might be the Renaissance, the Industrial Revolution, the invention of the printing press, the telecommunications, all these different revolutions that have happened in other times. But what's happening right now is simply unprecedented. I think in a large part, what's happened, it can be characterized by the following kind of little pithy story. Back when I was working on my PhD, say, in the early 90s in machine learning, a lot of us used to say that neural networks and machine learning were the second best way of doing almost anything. And that was true, and that you could handcraft a solution that would be better than what a neural network or some other machine learning system could do. But the ability to take a certain toolbox, like the machine learning toolbox, and apply it across multiple domains and come up with something that was good enough for most applications, that was powerful. But it wasn't revolutionary, because again, it was the second best way of solving almost anything. What has changed now, and what is truly mind-blowing to me, is that machine learning approaches for a wide variety of problems are on their way to becoming the first and the best solution for almost everything. And so when you take a look at lots of different minor revolutions that we've experienced. So for example, we went from this point where speech to text just didn't seem to work. And that was the state of the world 15 years ago. It was clunky, it was awkward, and most people who tried to do speech, the spoken word to text, quickly got frustrated with it and didn't use it. And now, because of the ubiquity of handheld phones and the data that has come from people just speaking in them, that virtuous cycle of collecting data, analyzing it, producing better algorithms and better solutions has yielded speech-to-text systems that are, almost at the same level of humans in terms of their ability to tease out words and vocabulary, given a variety of different audio sources and a variety of different contexts. And so that's almost magical to see that transition happen, because it's happening not just in the domain of speech, but we're also seeing it in machine translation, we're seeing it in self-driving cars, we're seeing it in a wide variety of domains. And so while it is an interesting moment of time right now where we still can be surprised, our expectations can be, we can be let down by our own expectations because we expect the cloud to be smarter than it is sometimes. We're at this threshold where the next thing that happens is it's going to have capabilities and be able to do things that will over-deliver. It'll be smarter than what we expected instead of failing. So I think in a lot of ways, I tell people right now is the most interesting moment in the history of the universe to be working in computer science, to be a programmer, or working in the cloud in some way. And I think this particular window of time will go down in history as a fairly magical moment.
And Adam, so what are the implications of this for the things that you're working on around Internet of Things and collecting that data and analyzing that data?
The implications are that we need to do three things at once. We need to provide our customers with the ability to effortlessly listen to, digest, and respond with context to their data. So that's step number one. But because while Gary is absolutely right that machine learning is increasingly becoming the best system, you need a fair amount of signal and a fair amount of data for it to really work reasonably well. And sometimes you have to jumpstart that data. For example, if the car vendor were actually going to start taking proactive actions, it would probably want to take a bunch of different choices and figure out which were working best and be learning from the outcomes of those actions. The second thing is we need to enable not just our employees, our data scientists, but our customers' data scientists. It is becoming a fundamental part of the data processing paradigm. When I draw now data processing, I start with ingestion, and I talked about how do you do ETL and ultimately produce a 360 profile across this huge activity lake and this huge set of data coming in. But then I show this virtuous cycle between the data science, both taking this activity lake and the data profile as of the time these activities occurred, computing the things it wants to compute, and then updating the 360 profiles with the intelligence that it can glean, with the proposals, the actions, the predilections that it can figure out. And only then do you start to actually do segmentation and try and figure out who's doing what, because these tools are essential to both influence what they do and to describe who should do what. So data science has become an integral part of the data processing cycle in a way that it absolutely wasn't as recently as, when I left Microsoft in '99. And you can't really talk about data processing anymore without talking about this being part of the cycle. And, Gary, I think, said it accurately earlier with his analogy. There's just too much data and too many responses and too many intelligent processes running at too large a scale to have humans handling each one. We're talking about things where a single one of our customers is generating billions of events a day to us. At that point, you absolutely have to have automated intelligence deciding what to do. You cannot have a human stop and look at this, one-on-one, the way the stage code analogy worked, and say, well, looks to me like you should, clean your carburetors, assuming you still had carburetors. Instead, all of this has to be automated feedback because it just won't scale otherwise. So I think, when I have nephews and nieces in college, and they're all reasonably technical, and one thing I told all of them is, make sure you study data science, make sure you study machine learning, because largely speaking, I completely agree with Gary that algorithms, while important, are increasingly less important than understanding the specific set of algorithms that are about how do you automatically learn from data, which is so critical now.
We have a question from Twitter, and Arsalan Khan is asking about how do you make this available to customers who are not data scientists, who just simply want to use this data. And so what kind of burden does that put on you, and what do you go through thinking about the translation to customer use?
I'd like to take a stab at answering that, and I want to riff off of what Adam actually just said. It's true that normal people, that it's not necessarily reasonable for to push down on our customers that everyone has to become a data scientist. What we're seeing, though, is something that Adam alluded to, and I want to give a concrete example of it. I think of this, what I'm about to describe, as closing the loop. It's really the creation of the feedback loop as a fundamental part of the application's architecture. So hold that in mind just for a moment. And think back to one of the earliest, maybe the first time that you used your phone to do speech to text again. You were trying to dictate a text message or something else. In the earliest days of using text to speech on the phone, what would happen is it would make mistakes with a greater frequency than what we see today. And you would have to use your finger to press on the word that was incorrectly converted and make the correction. And sometimes you would just delete the text and put in what it should have been. Other times it got a little bit smarter and it would ask, which of these homonyms did you mean? That little piece of UI right there, where not only are you taking the input from the user, not only are you giving an answer that is tentative, but you're instrumenting the response from the user, the feedback as to whether that is a signal as to whether the output was correct or not, or could have been improved or not. That right there was, in some ways, the critical architectural moment for a lot of these machine learning systems, because it became part of the application itself to retrain it, to correct the system. And people probably didn't even realize it at the time, that when they made the corrections on speech-to-text systems, they were actually becoming participants in a huge machine learning system that was making speech-to-text systems vastly more accurate than they ever had been before. And now you multiply that by the billions of people that have phones that are speaking into their phones and interacting with them in that way, and suddenly you have a treasure trove of data, the likes of which would have been impossible to have gathered merely a year earlier or 5 years earlier. That data of spoken words, to the tentative answer of what the text should be and the correction given by a human times billions. That's the sort of fuel that you need to power a machine learning system. So in answer to your question, what do we do? How do we make things much more accessible? Well, in the future, I think that what we're going to find is that a lot of systems, whether it's enterprise software or consumer or in the healthcare or other domains, are going to have that property that you will interact with the system, it will give you an answer, and you might feel compelled to correct it or refine it or give a thumbs up or a thumbs down on what the response was, and that will be instrumented. And that will be instrumented times a billion. And by framing the application in that way, it will be self-improving. And it will be improved not just by your own interactions. Yes, it'll learn to mirror and build something of an implicit model of what you like and don't like. So scenarios like personalization are possible. But when you multiply that across whole populations, it will be learning the collective wisdom of all the people who are interacting with it. So it's that kind of feedback mechanism that will become, I think, the default way that people come to interact and learn and improve, so that you don't have to be a data scientist, you don't have to be a PhD in machine learning in order to get the benefit.
So mine is just a little different. I mean, as I said, my background is trying to democratize platforms. And, you know, frankly, the current state of data science is one I wrestle with. I completely agree with Gary's premise. And in fact, one of the core things we've done in the IoT Cloud that we've built is we've made it every possible outcome that comes out of every rule that you write, you can signal basically whether or not this yielded a better or worse result. So we've created an automatic way to create signal precisely so we can learn from the application of those rules which ones work better than others and apply machine learning to that. And so to the extent we can automate the learning process, we want to. But we have plenty of cases where the real problem is getting the data pulled together in the right shape or structure such that we can learn from it. And Gary and I have had numerous discussions within this company about to what degree can you automate that process, and to what degree is that still an art rather than an automatable process. Not the art of the math. There seems to be pretty well understood ways, once you have relevant data pulled together, to try various learning systems and figure out what's the best predictive model, but rather the art of getting the data into a reasonable state in the first place. And computers are so powerful now and so fast that there's a lot of discussion going on right now that you can try all possible permutations as part of the computing thing. What we've been looking at, though, is we've been trying to structure the systems so that it is very easy for you to describe pretty much what Gary just said, which is, I'm going to try something, and I will describe basically, based on an outcome, whether this was a good outcome or a bad outcome. And then I will ask the system to start picking the ones that work and not picking the ones that don't work based on that outcome. And that is pretty easy for us to automate. And that says we take the burden off the consumer, and the user essentially is training the system, as Gary said earlier. I mean, a great example that we all have a little bit of angst about is whenever someone on the customer service desk automatically answers something or picks an automated response and says that's the right response, he or she is training the system to the point where ultimately you might not need the customer service desk. And that is, and that is actually the goal, is to train that system to do at least as good or better a job in answering 99% of the questions. And so let humans just deal with the 1% that aren't susceptible to that. But the actual business right now is a little bit like good UX design. Right now, there is no magic that we figured out for how you can just automate good UX design. It's why design-centric product design has become so prevalent as we moved in this new age. And it's very similarly, we're still seeing that our customers are not hiring fewer data scientists, they're hiring way more. When I started doing this, I expected that maybe 5 or 10% of our customers would have data scientists looking at the data. At this stage, I would say it's roughly 85%. Now, we're going to big customers and they can afford that, but it's pretty interesting to see that something like 85% of the customers I'm working with already have hired a bunch of data scientists. They already have them looking at the data, and they already have them working on this. So, because they have to, because they simply can't afford not to apply this expertise to looking at the data. Otherwise, they can't take advantage of it. So, we're wrestling with this. We're wrestling with how do you democratize it, and where we can, which is mostly about automating the engagement patterns for human behavior. We're starting to try and automate that. Where it's harder, like for example, recognizing that a computer will, an engine will fail in a car, but where the signal is very distant from the actual outcome, and trying to correlate them is not easy. Right now, we're telling them they need data scientists, and we're trying to figure out how could we help our customers do that more easily. But democratizing that is still something I think is a little harder than Gary said. Democratizing the process of practicing it. Yes, everyone who's ever involved in any system that's self-learning is training that system. But building that system for any given signal is not always so easy, in my view. Yeah, I'll take a first stab because Gary will be more articulate, and I would rather go first. The truth is, I think what we're seeing is the beginning of an age where enormous amounts of business processes are basically automated artificial intelligence, and that you're right, they run automatically and almost scarily to take advantage of all the signal coming in, because it's not possible to keep up with it algorithmically. And as Gary said earlier, given enough signal, the data science has started to beat the algorithms. I first saw that when I was at Google. We were looking at click-through rate on ads. Click-through rate on ads is a startlingly easy thing to measure. And the data science started picking what ads should be there to be clicked on, and it began to beat anyone else's algorithm. And as hard as they tried, no one could catch up. And that was 11, 12 years ago, and I was watching this going, okay, that is the future. So the implications, to be blunt, are you have to harness this stuff. If you don't harness this stuff, it's essentially trying to bring your goods to market in a horse and buggy when other people are driving trucks. You will not be competitive. You will not be up to date. You will not actually be able to do as good a job meeting your customers' needs as someone else who says, I can actually learn from this data, and I can write a self-improving system, and I can actually use the customers in the way Gary described to help train that system. You're just going to lose. And so the implications are that the business processes increasingly will be automated. And we hear a lot about deep learning these days, which involves, again, other kinds of technologies that were relatively well understood a while ago, but simply weren't cost effective. But again, those systems, people start to rely on them. They're going to rely on them for image recognition. They're going to rely on them for recognizing whether or not something is actionable or not. And those business processes are going to be baked in very subtle ways. And very concretely, and then I'll hand it off to Gary. I had a gift I was rushing to my wife for her birthday a few months ago, and came home on her birthday. I had Amazon rushing it to be there in 2 days. Checked Uber. My ride was on the way to where I was taking her out for dinner. Checked OpenTable. The reservation was fine. Went to look for the gift, and there was no gift. But I had an astonishing piece of email that had just come in that said, your product was damaged in shipping. We are really sorry. We have rushed you a new copy, and it will be there tomorrow morning. Now, what was impressive wasn't the level of customer service, though that was nice. What was impressive was thinking that through and realizing that was a completely automated response. That fundamentally a business process for figuring out, was I worth rushing it to? Was it possible to rush that gift to me? And getting that gift rushed to me, and sure enough, at 10 o'clock the next morning, I dropped it off. That business process had almost certainly used intelligence and learning to figure out the optimal strategy for me, the customer, specific to who I am and how much I buy from Amazon, and taken the cost and the hit to do that. And that's not going to go away, right? That kind of constant use of intelligence, as opposed to some programmer writing a set of rules and saying, here are the rules in my code for what we're going to do. Here are the algorithms. Increasingly it won't be algorithms. it'll be data science. And the only time when it'll be algorithms is when you're jump-starting the system, you don't have enough response to start doing that learning. You're just getting the data up and going, but it's really priming the pump, in my opinion. Gary?
Yeah, I think Adam pretty much nailed it. I want to riff off of what he just said and spice it up with a couple of anecdotes. But here's the headline. Here's the summary. The pattern that we spoke about before, where you can design an application to be self-improving by having a feedback loop with the user, where the user is giving some sort of indication as to whether the system's working well or not, that can be generalized and expanded to the whole of a company's performance. And I think Google was really, as Adam said, really the first company to really kind of master that pattern. But a little bit of information, an anecdote, if you will, about how that evolved. So I was involved, I was the chief scientist or chief science officer of a company called Overture that invented paid search. Paid search in the very first incarnation of it was a very human-intensive activity. So we at Overture employed human editors to review every single listing that went on. We had an editorial standard on what could be matched in terms of a query to a listing that had to be met or exceeded. And the idea of introducing a fuzzy matching algorithm that had some intelligence on it was, at that time, not acceptable to our constituents because they wanted to understand, they wanted to have transparency with how the system worked. So we created the business model, but we right away had painted ourselves into a corner. We weren't allowed to really clearly innovate in a way that would be, less than transparent. But what we could do is we could do some things like, people understood what a spell corrector was, and that for example, at the time, we probably had 24 different variations of how people would commonly misspell Britney Spears as a search term. And so you can imagine that if you could automatically figure out all the different ways of misspelling something like Britney Spears and mapping it to a canonical answer, that's a good thing for the user and that they'll understand. So, it was around 2002 where we built a spell corrector of that nature. It had to operate in 5 milliseconds, and it processed about 60% of all of the queries around the world going to all the different search engines. That's kind of the scope that we had. And that system was able to improve and in 5 milliseconds could correct the misspelling of Britney Spears and among other things. And what was amazing was when we turned that on, that created tens of millions of dollars of found revenue for Overture, the company. Tens of millions at that time, just from spell correction, which is truly kind of mind-boggling when you think about it. And so this was, for us, a real indicator that if we were going to succeed, what we had to do was we had to make our system self-improving. We had to actually analyze the flow of the data and change the functioning of the business as a result. Now, I had said earlier that we had kind of painted ourselves into a corner, and Google had the good fortune of arriving second into this particular race, and they designed it right on day one to be a self-improving system. So they used click-through rates as a way of assessing search quality rather than, say, a human editor. They had self-serve models for how both customers and would sign up for advertising, or how distribution partners would sign up to show ads. They really automated the whole thing. And as a result, whereas we had many humans in the loop for trying to automate it, they did not have a human in the loop, and they could actually do the whole thing algorithmically. And so what happened was that in a span of about 18 months, Overture was asleep at the wheel because of they were kind of acquired by Yahoo, and as we all know, acquisitions, big acquisitions sometimes slows things down. Google had the benefit of accelerating that process, and they went on to kind of conquer the world in some ways, the world of paid search as a result. So the bottom line here, and in answer to your question, what does your audience really need to think about? I think the answer is, how can you reframe, re-express your business to be more like Google or to be more like one of these other canonical companies that is optimizing their very business model through the flow of data and information that flows through it. And so how can you get that feedback loop? How can you architect your whole business so equivalent of that instrumentation of the user giving some correction to the system? That could be a customer complaining, a customer sending a thank you, or any number of signals that customers give us explicitly and implicitly for how we're doing our jobs. And using that to literally improve the performance of the whole company I think is the future.
We have just a few minutes left. We're just about out of time. So Adam, maybe some final thoughts from you on what we've just been talking about, and especially this implication on customers, their business models, the things that you were talking about and Gary was just talking about. And then Gary, we'll come back to you for final thoughts, and that'll be that.
Yeah, I think, Gary picked one of my favorite examples. When I got to Google, I wondered how was it that there was essentially this universal magic spell checker that knew every first name and last name of everybody in the world. And I went around and asked, and it was really just brute force data. Every time you typed anything and no one clicked and then typed something else and did click, it was a possible misspelling. If you got a certain number, it was a probable misspelling. If you got a certain ratio, it was a certain misspelling. It didn't even require machine learning. It was unbelievably efficient brute force.
Statistics.
And, right. And I think, my mind, my jaw dropped because they had designed the system, the way Gary just said, they had designed the system to be self-learning by counting. I mean, this did not require LDA or LS, and this was, counting. They had built this beautiful thing. And I think that, I can do no better in the last minute than to say what Gary just said, which is to the extent you can design every system to have a feedback loop. And the feedback loop tells you basically whether something is working or not working. And then you can figure out, and better yet, what did work. Like when my son asks Alexa to play a song and doesn't understand and he asks again, I am sure Amazon is trying to then learn how could they have understood that song in the first place. And if they're not, they should be. And that feedback loop is everything. Because if you can design the system to just count, never mind do data science, already you can do an extraordinary job compared to what you would do if you didn't design the system that way. So I think Gary nailed it. That is the essence, and it's so simple to start with. The essence of what we're learning is take your data, take your customers' actions, and use the combination to learn how to deliver better service.
And Adam, just very quickly, any advice that you have for your customers and for the people that are listening in relation to?
Well, we tell them all the same thing. We say, look, it's a whole new world. It's like when the web came along and it was a whole new world. Pick some very simple things to start with. Pick some subset of the signal you care about. Build a lot of POCs very fast, and we try to help them build a very agile platform. Test them all, get them learning, and learn as you go. Don't try and boil the ocean. Don't try and rebuild your entire business at once. Pick the most simple, most valuable thing you can think of, do that. Now think the next most valuable, next most simple thing. Do that. Try 7 or 8 or 9 riffs on that. Just be super agile, super fast, just as we used to be with websites. Start learning how to do and operate in this new world, because the sooner you learn, the sooner you get good at it.
And Gary Flake, you'll get the last word here. What's your advice and the distillation of everything that you know and what you can share with your customers right now in about a minute?
Well, in terms of the outlook that and the advice that Adam just gave for the immediate and near-term future, I don't think I can improve upon that. But what I'll do is I'll make an attempt of extrapolating this out a little bit further into the future. We talked about this virtuous cycle, this feedback loop, as something to embed within an application, and also as something to embed within a business. There's also a great deal of discussion and debate and concern around the future of artificial intelligence and the future of humanity and what this means. And depending on who you talk to, you'll hear 2 very different stories. One is that we're on the threshold of an AI utopia, and then we're on another threshold of the AI apocalypse. And so, depending on who you believe, you could either take a very optimistic or pessimistic view of the future. I think that the more likely path is actually a third path that's a little bit in the middle, and that is taking that feedback loop and applying it to one person. In the future, we will be interacting with our environment, both in the raw, okay, in the sense that as we do today, but we will also be interacting in the environment through some layer that is effectively assisted with some of these technologies. And if you think about how that feedback loop as applied to one would operate, it could actually be something that is really revolutionary for one person and what they can do and what they could be capable of doing. And so my whole thing is, don't fear the future. Don't fear the AI apocalypse or the AI utopia. Instead, I think that there's going to be a world in which humans and machines are actually working together in a way that the combination is much more powerful than any one piece alone. And so to the doomsayers or the people that fear for humanity, I say that yes, AIs will become incredibly powerful, but there will always be one thing that's much more powerful than an AI, and that is a human working in conjunction with an AI.
Okay, wow. This has been a fascinating conversation with Gary Flake and Adam Bosworth from Salesforce. Gentlemen, thank you so much for taking the time and talking with us today.
My pleasure.
It's been great. You have been listening to episode number 171 of CXOTalk. Come back next week. We'll be talking with the Chief Technology Officer of Accenture. And thank you as well to Kathleen Obata and Michael Ellis from Salesforce for helping us get all of this set up. Thanks, everybody. Have a great week, and we'll talk with you soon.